Good morning, everyone. In this lecture, we will discuss about load duration curve. Before this lecture, we have already discussed about different type of loads and different type of curve which is used in power generation process. So, the learning objective and outcome of this lecture is that after this lecture, student will be able to understand different type of loads, different type of load curve, and student will be able to understand that how can we calculate average load, maximum demand, utilization factor, and diversity factor. So, first, the content of this lecture is introduction about energy, types of loads, and maximum demand, average load, diversity factor, utilization factor, and advantages and disadvantages. So, what is energy? First, we have to understand that what is the unit of energy and what is energy. So a unit of energy is your kilowatt hour in terms of electrical. Okay. So 1 unit means that 1,000 watt which you are consuming in 1 hour, that is your 1 unit. For example, if you have uh, two bulbs, that is your 100 watt. So total, sorry, suppose you have, for example, we take a small example that you have one bulb which is your 100 watt, and this bulb is you are turning on for 10 hours. Okay, your bulb is glowing for 10 hours, then the total consumption of this bulb will be 100 into 10. It is becoming 1,000 watt. So 1,000 watt means 1 kilowatt in 1 kilowatt per hour. Okay, so 1 kilowatt hour means in 10 hours you are consuming 1,000 watt. It means you are consuming 1 unit in 10 hours. Okay, so 1 kilowatt hour is also represent the unit, or you can say energy in electricity terms. Okay, we have already discussed about the different type of load, which was your domestic load, industrial load, and your agriculture load, irrigation loads. And we have already discussed that when these load required electricity, and what is their peak and off peak hours, and what are their maximum demands. Okay, so these we have done in our previous lecture. In this lecture, we will discuss about load curve and load duration curve. So load curve is uh, drawn between always drawn between time on x-axis, 24-hour time on x-axis, and the demand or the load required on y-axis. But load duration curve is drawn or always between in descending order. First we take highest our maximum or highest load for that particular hours, then we will take another load which is less than your maximum load. So like this, we in descending order we draw our load duration curve. And there are some factors or some definitions which is very important for analysis of your power plant and load curves and your electricity calculations. So this is your average load, diversity factor, utilization factor, and some other definitions we will discuss in this lecture. And what are the advantages and disadvantages of these curves. Now, first we have to understand that what is your connected load. Okay, for example, uh, actually, for example, first we will understand the definition of connected load. Then we will take an example. So it is the sum of continuous ratings of all the equipment connected to the supply system. Okay, that is your connected load. That how many appliances are connected to your supply system, that comes into the category of your connected load. A power station supplies load to thousands of consumers. and each consumer has his her certain equipments installed in his premises. So the sum of the continuous rating of all the equipment in the consumer's premises is the connected load of the consumer. For instance, if a consumer has connection of 500-watt lamps and a power point 500 watts, so the connection load is your 5 into 100, 500 watt, and a power point which is your 500 watt. Then the sum of these total load is your 500 watt plus 500 watt. This becomes your 1000 watt. So the sum of the connected load of the all the consumer is the connected load to the power station. So the connected load for this consumer is your 1000 watt, right? Now, next we come to the point which is your maximum demand. It is the greatest demand of load on the power station during a given period. The load on the power station varies from time to time. The maximum of all the demands that have occurred during a given period is the maximum demand. So, referring back to the load curve of figure, which was given in your last curve, that in last lecture I explained the maximum demand between from 6 p.m. or 7 p.m. to uh, 6 p.m. or between 9 p.m. That was 6 megawatt. So maximum demand is a demand which is maximum over all the period. That is your maximum demand. So maximum demand is generally less than the connected load. Okay? Suppose in your house you have 10 electrical appliances, like you have 5 fan and 5 bulb, one refrigerator, one cooler, and one AC. But at a time you are not using your 10 bulb, one fridge, and one cooler, and one refrigerator. You can't, you are not using these appliances simultaneously. Okay, so your connected load may be 1000 watt, 1000 kilowatt, or 500 kilowatt, but your maximum load is always less than your connected, right? Are you getting my point? That your connected load is always greater than your maximum demand. If you have 10 bulb in your house, then you are not, you can't use these 10 bulbs at a time. So your maximum demand is always less than your connected load. So maximum demand is generally less than the connected load because all the consumers do not switch on their connected load to the system at a time. So the knowledge of maximum demand is very important and it helps in determining the installed capacity of the station. So the station must be capable of meeting the maximum demand. Now, what is your average load? So the average load occurring on the power station in a given period, day or month. Suppose you are having um, uh, for particular hours you are consuming like 200 megawatt, for next particular hours you are consuming 100 megawatt, then the average load will be your total load divided by the if you are if you want to calculate in a day, then you have to divide this load by 24. If you want to calculate this load for a month, then you have to divide it by it into 30 into 24. If you are calculating for a particular year, then you have to divide this load by 360 into 24. So this is by this calculation we can easily calculate the average load. Okay, now hope you are able to understand that what is your connected load, what is your maximum load, and what is your average load. Maximum load is always less than your connected load, and average load is the total load which is divided by the particular time. It will depend that you are calculating it for your or a day or a month or a year. So is it clear? Now next we come to the next point, that is your daily average load. So this is the formula for your daily average load, which is equal to number of units generated in a day divided by 24 hours. Okay, like this, your monthly average load, which is equal to number of units kilowatt hour generated in a month divided by number of hours in a month. And like this, it is your yearly average load, which is equal to number of units kilowatt hour generated in a year divided by total hours in a year. So by the three formulas, you can easily calculate your daily average load, monthly load, and yearly load. Hope you are now it is clear to you. Next, we come to the point load factor, which is very important topic. And what is load factor? Okay, so it is the ratio of average load to the maximum for a certain period of time. This is your load factor. The load factor is called daily load factor if the period of time is a day, and if the period of time is a month, then this is called your monthly load factor. Similarly, if the period of time is your year, then this is called your yearly load factor. Because your average load is calculated for your daily basis, monthly basis, and yearly basis, right? So, the we have done about connected load, maximum demand, and your average load. So the load factor is the ratio of your maximum load is divided by average load. So this is your load factor. The formula for this load factor is equal to average load is divided by maximum demand. If the plant is in operation for T hours, suppose your plant is operating for T hours, then the load factor will be average load into divided by T upon maximum demand into T divided by T. So unit generated in T hours and maximum demand into T hours. We will discuss it in a numerical, so you will be able to understand it easily. Now next is your the load factor may be daily load factor, monthly load factor, and annual load factor. If the time period considered in a day, that is a daily load factor. If the time period is considered for a month, that is your monthly. And if time period is considered for a year, that is your yearly load. So load factor is always less than 1. Why is it so? Because you have seen the formula that load factor is always equal to average load upon maximum demand, and maximum demand is always greater than your average load. Okay, for example, mm, in your house that you have connected 4 bulbs, which is your 100 watt, so total load is your 400 watt, and you are connecting a fan that is your that is also your 100 watt, so total load is your 500 watt. At a time, you if you want to calculate the average load of this, then you have to suppose you are using uh, 20 megawatt for 1 hour, and sorry, 100 watt for 1 hour, 200 watt for next 3 hours, then you will calculate the average load. When you will divide this average load by maximum demand, suppose you are 200 megawatt, 200 watt, then the load factor is always less than 1. So the average load is always smaller than your maximum. So the load factor plays a key role in determining the overall cost per unit generated. Higher the load factor of the power station, lesser will be the cost per unit generated. If your average load is always less than, it is always minimum, then the load factor will always be less than 1. If you are your average load is high and maximum demand is less, then you will get a higher load factor. Higher the load factor of the power station, lesser will be the cost per unit generated. Now, the important point is your diversity factor. So, diversity factor is the ratio of the sum of individual maximum demands. Actually, there are different consumers. So, we have to calculate the maximum demand of different load. Then we will divide this demand factor. We will calculate the maximum demand of different loads, and the sum ratio of the sum of individual maximum demand is divided by maximum demand of the power station is known as diversity factor. So a power station supplies load to various types of consumers whose maximum demand is different, generally do not occur at the same time. Suppose there are four houses, so maximum demand of that four houses will be different, and it will be different at different time. Okay, so the maximum demand generally do not occur at the same time. Therefore, the maximum demand do not occur at the same time. What you have to do? The uh, Therefore, the maximum demand on the power station is always less than the less than the sum of individual maximum demand of the consumer. For example, a power station which is connected to the four consumers. One consumer having his maximum demand at a different time. Second consumer will have his maximum demand at different time. Third consumer also will have his maximum demand at different time. Fourth consumer will have his maximum demand at different time. But the power station maximum demand will be different. Okay, so therefore the maximum demand on the power station is always less than the sum of individual maximum demand of the consumer. So diversity factor will always be greater than to the 1. So load factor is always less than 1 because the formula of load factor is equal to average load upon maximum demand, and average load is always less than to the maximum demand of a particular consumer. But diversity factor, actually you can differentiate these two, that load factor you are calculating for a particular consumer, but diversity factor you are calculating for a group. Okay, so load factor is always less than 1 and diversity factor will be always greater than 1, because it is the ratio of demand in individual maximum demand, which is divided by the maximum demand of power plant. So diversity factor is always greater than 1. The greater the diversity factor, the lesser is the cost of generation of the power plant. So the formula for diversity factor is equal to sum of individual maximum demand is divided by maximum demand on power plant, which is in kilowatt. Now next come to the point which is very important, plant capacity factor. So it is the ratio of actual energy produced to the maximum possible energy that could have been produced during a given period. So formula for plant capacity factor is equal to actual energy produced and maximum energy that could have been produced. Suppose a plant has its capacity to producing, suppose 500 megawatt, but it is producing 400 megawatt. Okay, so 400 megawatt is divided by maximum 500 megawatt. So this define the plant capacity factor. So another formula for plant capacity factor is equal to average demand upon plant capacity. Okay. So if the considered period is 1 year, so annual plant capacity is equal to annual kilowatt hour output upon plant capacity into 8760, which is hours in a year. Okay. So basically, you can define that the plant capacity, like the rated capacity of a plant is suppose 500 megawatt, but it is using only 400. It is producing only 400 megawatt. So this is your plant capacity factor. So the plant capacity factor is an indication of the reserve capacity of the plant. A power station is so designed that it has some reserve capacity for meeting the increased load demand in future. So we have seen that the day by day your energy demand is increasing. So it is not possible to set up a plant again from zero. So we have to take some reserve capacity for our future planning. Okay. So it has some uh, future reserve capacity, and future demand can be calculated by your forecasting methods, load forecasting methods. So that is a different topic, we will discuss it on next unit. So it has some reserve capacity for meeting the increased load demand in future. So therefore the installed capacity of the plant is always somewhat greater than the maximum demand on the plant. So reserve capacity can be defined as plant capacity minus maximum demand. Okay. So it is interesting to note that the difference between load factor and plant capacity factor is an indication of reserve capacity. Uh, so if the maximum demand on the plant is equal to the plant capacity, then load factor and plant capacity factor will have the same value. So in such a case, the plant will have no reserve capacity. So this is very important point. So now we have discussed about our average load, maximum demand, your load factor, your diversity factor, and your reserve capacity. Hope you are able to differentiate between these particular definitions. Now, next is your plant use factor, which is equal to station output in kilowatt hour divided by plant capacity into hours of use. Next, we come to the next point. The utilization factor or use factor is the ratio of time that a piece of equipment is in use to the total time that it could be in use. So it is often averaged over time in the definition such that the ratio becomes the amount of energy used divided by the maximum possible to be used. We will take an example by which you will be able to understand the utilization factor, and uh, the formula for utilization factor is equal to maximum demand kilowatt divided by installed capacity. For example, if a plant has a maximum demand is kilowatt in suppose 100 megawatt, 100 kilowatt, and its installed capacity is 200 kilowatt. So 100 is divided by 200, that is always less than 1. Okay. So like this, we can easily calculate the utilization factor. Now, diversity factor is commonly used, this is your diversity factor we have already done, but again we can see because it is very important. So diversity factor is commonly used for a complete coordination study for a system, because you have seen in that our previous slide that yes, diversity factor you can see by this formula sum of individual maximum demand, and this is divided by maximum demand on power plant. If you are able to find out your diversity factor, like different user which using maximum demand at different time, if you are able to calculate this diversity factor, uh, uh, then diversity factor you will be able to coordinate a study for a system, and this diversity factor is used to estimate the load of a particular node in the system. So diversity factor can be used to estimate the total load required for a facility or to size the transformer. If you are able to calculate diversity factor very effectively, then you can easily find out that which size of transformer you required at a particular node. So it is very important. Now we come to the example. So from the example is a generation station of 1 megawatt supplied a region which has the following demands, uh, from midnight to 5 a.m. 5 a.m. to 6 p.m. it is no load requirement. 6 p.m. to 7 p.m. it is 800 kilowatt load requirement. 7 p.m. to 9 p.m. it is required 900 kilowatt. 9 p.m. to midnight it requires 400 kilowatt. So uh, what you have to do first, you have to draw the daily load curve and the load duration curve, which we have already drawn in our previous lecture. And the second point is you have to find the load factor, the reserve capacity, the plant capacity factor, and plant use factor, and the hours that the plant has been off and utilization factor. So we will discuss the second point in this lecture. Now, when the transmission line losses are neglected, in this calculation we will neglect the transmission losses. So generation is equal to the demand, okay, and the demand is equal to load, okay. So installed capacity is 1 megawatt, like 1000 kilowatt, and maximum load is your 900 kilowatt, which is already given, that the generating station of 1 megawatt. So 1 megawatt is its installed capacity of power plant. Okay, it can generate 1 megawatt electricity or 1 megawatt energy, 1 megawatt of power. Okay, so power generation of this power plant is 1 megawatt. Now, 1 megawatt can be written as 1000 kilowatt, and from the table you can see that the maximum demand is your 900 kilowatt. So the maximum demand is your 900 kilowatt. So the average load is equal to area under the load curve, okay, which is uh, which is the formula of average load, that is area under the load curve kilowatt hour and number of hours. Okay, when you will draw the graph of load duration curve, you can easily find out this, and you can see here that from midnight to 5 a.m. Okay, so it is 5 hours. You are using 100 kilowatt power. So 5 into 100, this is your 500, plus for next 13 hours. Okay, there is no load, 5 a.m. to 6 p.m. There is no load. This is your 12 hours, 13 hours, which is divide in multiply by 0. Then for 1 hour you are using 800 kilowatt. So 1 into 800 kilowatt. Then you are using 900 kilowatt for 2 hours. So 2 is multiplied by 900. Then 3 for 3 hours you are using 400. So your load which you are using for a particular time period is over here. This can be calculated by under area under the load curve. So you can see that uh, the uh, total load demand is this, and this is divided by 24. So you will get that the average load is your 179.16 kilowatt for a day. Okay. This load it is your average load for a day. Now this is your load curve and this is your load duration curve. Now we have to calculate load factor. So you know the formula of load factor, which is your average load upon maximum demand, and the load factor must will always be less than 1. So average load will never be greater than your maximum demand. You can see from this formula that the average load is not higher than your maximum demand. So your maximum demand for this question is 900 and your average load is your 179.16 kilowatt. So you can easily calculate the load factor, which is equal to average load upon maximum load, and average load is your 179.16 kilowatt, which is divided by 900 kilowatt, and the load factor is your 0.199, and if you calculate it in the percentage, then it will be 19.19% load factor. Okay, now we come to the next point, that is your reserve capacity. So we have already done in our previous slide that reserve capacity formula is installed capacity minus maximum demand, and the installed capacity of the power plant is 1 megawatt. Okay, and the maximum demand is your 900 kilowatt. So 1 megawatt can be converted into kilowatt, that is your 1000 kilowatt minus 900 kilowatt, it is 100 kilowatt. So the reserve capacity is equal to installed capacity minus maximum demand. Suppose your installed capacity and maximum demand are same, that there will be no reserve capacity. Is it clear? Now, next we come to the plant capacity factor. So average demand is your 179.16 kilowatt from this power plant, and installed capacity is your 1 megawatt. So what is your plant capacity factor? It is your 17.91%. So the plant we are using, which has the capacity of 1 megawatt, is not fully utilized. Plant use factor. The formula for plant use factor is actual energy produced in kilowatt hour divided by plant capacity into number of hours. So you can calculate this from that your average load is 4300 kilowatt hour. Okay, so actual energy production is 4300 kilowatt hour, and your plant capacity factor is your 1000 kilowatt hour, and number of hours which is you are using this load, you can see that this average load is utilizing 1 2 3 4 5, and this is your 6 hours. Okay, so 5 1 2 3 4 5 5 hours, and this is your 6 7 8 9 6 7 8 6 7 8 9 10 and 11. So total hours is your 11 hours. So this load is utilizing for 11 hours. So the plant use factor is equal to 39.09%, and your plant capacity factor is your 17.91%, and plant use factor is your 39.09%. Now we come to the utilization factor, which is your maximum demand upon installed capacity. So utilization factor is your 90%. You are not utilizing this power plant at 100%. That's why you are getting reserving capacity of 100 kilowatt. Okay. So by using these calculation, you can easily calculate this. You can easily calculate the load factor, utilization factor, and plant use factor, maximum demand, and average load. Now we come to the next point, next question that, for example, a generation station has a maximum demand of 20 megawatt, a load factor of 60%, plant capacity factor is 48%, and plant use factor of 80%. Actually, in this question, the maximum demand is given, the load factor is given, plant capacity factor is given, and plant use factor is also given. So you have to calculate the daily energy produced, that how much energy it is producing in kilowatt hour, the reserve capacity, which is your plant capacity minus maximum demand. So you have to calculate maximum demand also. Then the number of operating hours per daily, and the maximum energy that could be produced daily if the generating station was running all the time. Okay, so this is very important example. For the solution, we come to this point that find the daily energy produced. So load factor is given. So what is the formula of load factor? Which is equal to your average load divided by maximum demand, maximum load. So average load, first we have to calculate the average load. Load factor is your 60%. So this is your 0.6 is equal to average load or divided by 20 megawatt, and 20 megawatt is your maximum demand, which is given in the question. So you can easily calculate that your average load, which is 12 megawatt. What is the formula of average load? Area under the load curve upon number of hours. In so the number of hours is 24 hours, and average load, average and area under the load in kilowatt hour means this is the energy which is generating, this is the energy which is producing. So 12 multiplied by 24, this is your 288 megawatt hour. So this is your energy producing through the power plant. Now find the reserve capacity. So first you have to find out its installed capacity. So installed capacity can be easily calculated through plant capacity factor, which is equal to average demand upon installed capacity. So installed capacity is equal to average demand upon plant capacity factor, which is already given or we have calculated. So this is equal to 25 megawatt. Now we come to the next point. This is your reserve capacity. So installed capacity of plant is a 25 megawatt, and the maximum demand is already given in the question, which is your 20 megawatt. So reserve capacity is equal to 5 megawatt. The third part of this question is you have to calculate, find the number of operating hours per daily. So plant use factor is equal to average demand into time divided by installed capacity into number of operating hours. So from this formula, you can easily calculate the number of operating hours. 0.8 is equal to 12 into 24 divided by 25 into number of operating hours, and number of operating hours is equal to 12 into 24 divided by 25 into 0.8. This is equal to 14.4 hours. So this is all about this lecture, and I think you are able to calculate your load factor, your diversity factor, and your maximum demand and average load, plant capacity factor. Okay, now these are some questions which is based on your previous and this lecture. So what is the advantage of sectionalizing of power plant? That is that you can get high reliability electrical energy, which is very important. The area under the load curve represent the average load on power system, maximum demand, numbers of unit generated, or load factor. So the area under the load curve uh, is represented by is always represented the energy which is producing from your power plant, and in power plant the energy which is producing is always calculated in the term of units. So this is your number of units generated. So the right answer for this question is C. Next, which of the following is equal to the maximum demand? So the ratio of area under curve to the total area of the rectangle, the ratio of area under curve and number of hours, the peak of the load curve, the area under the curve. You can easily calculate maximum demand, that will be your peak hours. Okay, now load duration curve indicates the variation of load during different hours of the day, total number of units generated for the given demand, total energy consumed in by the load, the number of hours for which the particular load lasts during the day. So it always shows that the load during different hours of the day. Which of the following is called as cold reserve? Reserve capacity available but not ready to use is always called a cold reserve. Now, coincidence factor is reciprocal of actually coincidence factor. We will discuss it in the next lecture. Now, in practice, what is the value of diversity factor? So you have seen in your uh, previous slides that I have already explained the formula of diversity factor. So diversity factor is always greater than 1, and you can see that because it is the sum of individual demand and just a wait. Yes, it is equal to sum of individual maximum demand and divided by maximum demand of the power station. So it will always be greater than 1. Okay. Now, the right answer for this question is it will always be greater than unity. It will not be less than unity. It will not equal to or greater than unity. It will not less than 0. It will always be greater than unity. Now the load factor is, we have already done, the load factor is equal to average load is divided by maximum demand, and average load is always less than your maximum demand. So load factor is always less than 1. So always less than unity, less than or greater than unity, always greater than 1, and less than 0. So the this will be always less than 1. So A is the right answer for this question. Now we come to the next point. What is demand factor? So we have already discussed about your demand factor. So ratio of connected load to maximum demand, ratio of average load to connected load, and ratio of maximum demand to the connected load, ratio of kilowatt hour consumed to 24 hours. So you can easily find out the answer for this demand factor. Now next question is, your size and cost of installation depends upon your maximum demand. The reference of this lecture is Generation of Electrical Power by B.R. Gupta and NPTEL. By going through these references, you can easily understand the load factor, load load duration curve, and utilization factor, reserve capacity, and your mass curve, chronological curve. So you can easily understand by this by these book or some NPTEL lectures. So this is all about your uh, load duration curve, by which you can easily understand the different factors which is important for your power generation plant. Thank you.